Okay, so hello everyone, welcome. Can you hear me?
Yes, sir.
Yes, sir.
Okay. So just we are waiting 1 or 2 minutes for joining all of the participants. Then we will start the session. Okay, so now we will start. Okay, so I hope you also get all of those recorded video class as well also get the practice code and also practice. And when you face any problem, just let me just put in this problem in this WhatsApp group. So here you can get the supported from this group. Okay. And basically today I will try to discuss about that air quality monitoring, how we can easily do using the Google Earth Engine platform, also remote sensing technique, how we can easily make the different types of air quality parameters density map, as well as also make the time series analysis, and also make the how can easily download the data directly in the Excel file, as well as also make the total emitted gases for any particular gases for any particular place, how you can do that. So this type of air quality parameters we try to discuss. So let's go. Just I simply share my screen. Okay, can you hear me? Kindly open your Wi-Fi. Open your Wi-Fi, please. Okay, can you hear me? Hello. Okay, I think some problem for networking. Just check it. Just a minute. Kindly open your Wi-Fi. Kindly open.
No.
Yeah.
His
So
network is very bad.
okay. So now it's okay. Yeah. So now can you hear me? Yeah. So now can you hear me?
Yes, sir. Now it's audible.
Yes, yes.
Okay. I faced some networking issue for suddenly. Okay. So now we'll start. Okay. So just I simply share my screen. Okay. Okay. So let's go. Just I simply open my slide. So basically today is our fifth number of class, and mainly today I will try to discuss about that air quality monitoring, different types of air quality parameters such as nitrogen dioxide, carbon monoxide, sulfur dioxide, methane, then ozone. Okay, this type of air quality parameters, how we can easily make the density map using the Google Earth Engine platform, as well as how you can easily download the air quality parameters time series data in Excel file or CSV file. Directly we can download the data in Excel file or CSV file. Then how to convert the unit mole to meter cube, mole to per meter square to molecules per centimeter cube, as well as how you can easily make the time series chart, and also how to export this map and use the ArcMap software, as well as we also try to discuss about that how we can easily calculate it, the total emission of any types of gas. It can be nitrogen dioxide, sulfur dioxide, total emission, how can easily calculate it for any particular gases with a particular specific time period. Okay, how many gas is emitted, such as year of 2022, month of January in Bangladesh, how many nitrogen gas is emitted. So this type of calculation, how can easily perform using the Google Earth Engine platform, we try to discuss about that. So let's go. So here you can get the two types of map. So basically this type of map we created using the ArcMap software. So basically this type of TIFF file, we can simply download it from Google Earth Engine platform. After that, we can simply make this type of map using the ArcMap software. Okay, as well as first map is the methane concentration map of Kuwait. Unit is the ppb, and another map is the nitrogen dioxide concentration year of 2020 January. This is the mole per meter square. Okay, As well as also you can see nitrogen dioxide level rebound for the different time period in Bangladesh. So before lockdown, in COVID situation, during lockdown and post lockdown. Okay, so we also distributed the where it will be high, low, medium, very high, high. We distributed for the different time period for our research paper and other, as well as basically all of those things, all of those data we extract from the Google Earth Engine platform, and after that final this type of map create using the ArcMap software. Okay, so now air quality monitoring using the mainly we are using here the Sentinel-5 satellite imagery, and Sentinel-5 satellite imagery it mainly accessing the different types of air quality parameters such as ozone, then nitrogen dioxide, then formaldehyde, aerosol, carbon monoxide, methane. So this type of gases information we can easily access from the Sentinel-5 satellite imagery, and this is the data set link about that. You can simply go to this link and you can easily find out all of those data about the Sentinel-5. All of the Sentinel-5 data we can easily access from here. As well as you can simply open your code editor and simply go to the top of the code editor search bar and go to the browse data catalog. Then we can also find out this dataset link. So just simply click on here for the browse data catalog. And then go to the Sentinel. So here I find out all of the Sentinel image collection, Sentinel-1, Sentinel-2, then Sentinel-5. Okay. So just I simply click on the Sentinel-5 because in this time we are using here the Sentinel-5 tropospheric monitoring instrument, this satellite imagery, and find out for the different types of air quality parameters. Okay. So in this time here you can see all of those data about that, such as UV aerosol index, then cloud. Also you can see the carbon monoxide, then formaldehyde, as well as also you can see the nitrogen dioxide, ozone, then also sulfur dioxide, methane. Okay, all of those gases we can easily access from here and then monitor. Okay, so in this time all of those gases for the same process. Okay, so randomly in this time I will show you that data sets such as suppose methane. Okay, so I want to show you that about the methane concentration, and then also make the methane concentration time series chart, then also make the about the methane, how much methane gas is emitted in any particular time period for the any specific region. Okay, and how you can easily download the time series data for methane using the directly Excel file, okay, or CSV file, how you can easily download from here. Okay, so this is our data set. We can get the data set. This is the availability time period. We can get the data set within this time period. And this dataset provider is the European Union, yes, Copernicus, and this is the unique ID of this dataset. Okay, we can get all of this information about the dataset. So you can see all of this information about this dataset. We can get about the offline high resolution image of methane concentration. Okay, so all of this information you can get from here. So in this time I use this dataset and then try to find out the methane concentration. Okay, for any specific region. Okay, so let's go. First of all, what can we do? Same process, just simply copy the dataset snippet ID, simply copy that and paste on your code editor. After that, give a variable name. You can choose any variable name. Suppose I put the variable name is that I put the data. Okay, you can put any name. I put the variable name is the data. Okay, so now this image collection is imported in my data set. Okay, so if you want to check how many data set is available for, how many images are available for this data, just simply use the print function and call the data and use the size function and then click the run. So now it computed how many images is available for the whole world for the data set. We can get this large number of image collection about this data set. So in this time, this data set I need to filter, mainly using the filter date, filter bounds, as well as also reducer. We need to reduce for visualizing this map. So let's go. In this time, Suppose I need the dataset for a specific year or a specific time period. So just use here the filter date function and then put here the time period such as 2020, 1st January from 2020, December 31. Okay. So now let's check how year of 2020, how much image is available. Okay. So now you can check, we can get this number 4,853 images is available. Okay. So in this time, in this data set, we find out some band. You can see basically this band called the methane column number mixing ratio. This is the data set about that, and unit is the mole fraction. Okay, so in this time I just use this band, and basically this band represented the column average dry air mixing ratio of methane. Okay, and parts per billion. Okay, so in this time I use this, so I simply copy that and then use the function select function. Okay, just I use here this dot notation and put here the select and put here this. Okay, so in this time, if you want to check how many images about that, we can get the same number of images. Okay, so for this band also. Okay, so in this time I want to observe the data for a specific region such as country boundary of Bangladesh. So just I simply imported this country boundary of Bangladesh shapefile and put here this such as suppose RY. Okay, and the shapefile. This is my shapefile. I need this result for this area of interest. Okay, so now I can get this result look like that. Okay, year of 2020, this time period, and this result I want to visualize in this time. So in this time I simply take a variable. Suppose I put the variable name is that average or average concentration of methane. First I put the average data. You can use any name, and then I simply call my data because it is stored total 4,853 images. I call and paste here and use here the reduce function. I just reduce. I take the average result. So reducer dot mean. Okay. So now display the result about that. Use here the map dot add layer. In this time I get the result for the whole world. Okay, whole world methane concentration map year of 2020. Now click to the run. So it loaded for the whole world. So that's why it takes some time. And it also depends on internet connection. Working. Okay, so it's loaded because it also depends on the internet connection, and it make the result for the whole world. Okay, so I get the result. Suppose not whole world, I need the result for the suppose clip of interest, clip with my shape file, suppose clip with my RY. So then we can get the easily this layer will be loaded only for the Bangladesh boundary. In some networking issue. I think some network issue. Just a minute. I simply change my network. And run again this code. Okay, it loaded. Yeah, yeah. So now working. And in this time we can get the result look like the white color because I did not add any visualization. So I simply copy the visualization code from here. They already provide some default visualization. Just simply copy from here and then paste. And after that, just simply copy this variable name and put this variable name in that average data. After that, simply put in here. So now it also added the color. Okay, we can get the color look like that. Yeah. Okay, if we are ready. Yeah. Okay, we can get this type of map, but we can easily rearrange the color balance. Okay, in this time it a whole of the country showing the red color, so just we can change it and we can get the better result. Okay, so I simply check the value about that red pixel value. What is the pixel value about that? Yeah, so I simply copy that value or just copy and use here, and also check the this type of pixel value. Suppose what is the pixel, you can check it. Okay, then simply copy that, paste here. Now click the run again. Okay, so now we can get the sum distribution, and we can easily find out where is the high and where is the low emission of methane. Okay, so basically in this time we can get this result, and we are also mentioned about that mean will be, okay, sorry for that, it will be mean value. Okay, sorry, it's mean, and I put here the max. This is the max value. Okay, so now it correct format. So now click to the run again. Okay. Okay, so in this time we can get this. You can see black, it represented the low concentration, and red is the highest concentration. Okay, so it is also loaded in this time. Okay, so in this time we can get the red in the Dhaka city. So methane is a mainly, it's the hydrocarbon that is the primary component of natural gas, and methane is also greenhouse gas. Okay, so in the Dhaka city we can get the highest density of that methane. Okay, and methane is emitted of a variety of that anthropogenic or human influence and natural sources. Okay, so in this time we can get that, and you can see here mainly the forest region. You can see this is the forest in this time. that we did not find out any pixel value. These are the methane emission. We did not find anything about that forest, and we did not find out any about that river. You can see river. So there is a no pixel value about that emission of methane. Okay, so methane mainly emitted from a variety of anthropogenic or human influenced sources. Some natural sources is also we have on hand, but most of cases human influenced or is mainly emitted from the human influenced or anthropogenic way. Okay, and it is also the another methane is also greenhouse gas, and mainly it presents in the atmosphere, affect the earth's temperature and climate system. Okay, so in this time we can get the result. In this time look like that. You can see it also loaded. It not loaded properly yet because there's some networking issue, but it will be loaded. Then we can also get the better map about that. And in the meantime, you can see there is a forest. There is no pixel value, as well as we did not find out any pixel value about the river region. You can see there is no pixel value. So this step, it means that for this region, there is the no emitted of methane gas, or if it will be emitted very less, okay, which is not countable in this time. Okay, so it also loaded in here. And mainly we find out this more concentration about this methane in the Dhaka city region, as well as we can get this peripheral region of Dhaka city. Okay, as well as we can get the port region in here, also get the concentration of the methane. Okay, so we can get the overall figure of this methane concentration map of Bangladesh, look like that. Okay, so in this time we did not find out the pixel value in the river body, as well as we did not get the pixel value of the forest. Okay, also get the river, because there is the no emission of methane. If it will be emitted very less, so that's why it's not countable in this time in here. Okay, also you can see this region is also not there is any methane about that. Okay, okay, so now it's loaded. You can see, yeah. So now we can get the fully map about this region. Here you can find out about this region, look like that. Okay, so in this time it take the time because the lot of data set 4,000, okay, 4,853 images produce this average pixel value of this map. If I want to take here the only for the 1 month, such as I need the result for the month of January, so then put here the 01, and now I can get the result very quickly. Okay, only 297 images for the month of January. Okay, and it will be loaded very quickly. You can see. Okay, now I can get the result look like that. Okay, so month of January, I find out the data for look this type of data distribution of the methane. Okay, some region is not showing this because in this time there is a no emitted pixel value in this region, and if it will be emitted, then it very less, which is not countable. Okay, so this is the map represented, and only for those region where I can get this type of color, only for those region is emitted the methane, and other region is not emitted. Okay, as well as suppose you need the 2-year data set, just put here this February or March. Okay, January to March, then click to the run. Now I can get this total 1,105 images, and it also showing this result about that, look like that. Okay, so this is the process for visualizing the methane about that. In the same process, we can also apply, suppose I want to work with for the nitrogen dioxide. So what can I do? Just I simply open the nitrogen dioxide. So this is the methane, and suppose I want to work for that nitrogen dioxide. Yeah, nitrogen. Simply click on the nitrogen dioxide. And open a new code editor.
So I have a question.
Yeah, please.
So like in methane's thing, you have shown that the area which is not emitting methane, that is blank. Okay.
Yeah.
So that area that is not emitting methane, or the minimum level of methane is less than 1800 point something. That's why it is not showing methane. Because the minimum value we have taken 1800 something, na?
Yes. Yeah.
If the methane level is less than 1800 something, then there will be no pixels.
Okay. If has also available. So if you want to check it, suppose in this time I put here this visualize only for that. Okay. So and I also check it about the result. So in this time you can see here when I check about this result black, so black, it mentioned that lowest pixel value.
Yes.
I want to check it for any black region. Suppose this is a black region. Simply click on here. Then I can get about that overall black pixel result, about that this type of result I can get in here. Yeah. So I take it as a minimum pixel value from here, as well as red. In this time in this chart you can see the color plated is showing the red is the highest. Okay. So I take the highest pixel value about that. I get this pixel value look like that 1954. Okay, after that, simply paste in here. Then within this range, we can get all of those pixel value. Okay, and when you download the data, from here as a TIFF format, then we can get the accurate result, accurate all of those pixel value. In this time, this visualization is only showing on Google Earth Engine platform. Okay, and it also depend on my pixel comparison between the mean and max. Okay, but when I download the data from here, suppose average data is including here, when I download it as a TIFF format from here, then I can get what is the exact value of that mean and max. Okay, I can get the accurate value about that. Okay, for this data set, as well as we already discussed about the reduce region function. Okay, suppose in this time from this data set I want to observe about that. Okay, just a minute. Yeah. So can you hear me now?
Yes,
Yeah.
sir.
Sorry for that. Yeah. Okay. So in this time you can see here I check the pixel value from my map and work and put here the mean and max value. Okay. If you want, you can also calculate it from the data set. What is the minimum result from this data set? What is the minimum pixel value, or what is the minimum concentration of this map using the reduce region function? Okay, suppose I put here this reduce region function. We already discussed about the function reduce region, how we can easily calculate the reduce region function, and then make the map calculated the different types of statistical such as minimum, maximum. So this type of result we can easily calculate it. Then we can get only for those data. Suppose this data minimum value is that 8000, then we can put here the 8000. Suppose maximum, suppose 2000, then put here the 2000. Okay, but in this time we don't know what is that exact result about the minimum and maximum pixel value. So that's why we can check the pixel value randomly and put here this value and show the visualization. But if you want, you can also calculate the data. Suppose I calculated the minimum pixel value of this from the data set. So what can I do? Just I take a variable, suppose mean methane CS4, anything you can put. Okay, and then I simply call the data set. So this is my data. Okay, from this data I just calculated about that what is the minimum result. So put here that and use here the reduce region function, reduce region, and put all of those argument one by one. After that, first of all, reducer, I make a dictionary, so curly bracket start, and also put here the curly bracket end. And first of all, reducer, I want to put here the reducer as a minimum. Okay, so use that the ee dot reducer dot mean. Okay, and also put here your ROI, shape file variable name ROI. Scale is that our visualize okay, so what is the resolution about that? I check it. It is the methane. You can check the resolution from here. You can see the 1113.2 meter. This is the resolution about that data set. Simply copy that value and then paste. Okay, CRS and not need, simply remove that. Max pixel will also not need, remove. But when I face any problem, then I use the max pixel. Otherwise, max pixel is not need. And then remove that. Tile is not need, simply remove that. And after that, when I print this result, what is the minimum result of this methane concentration? So I call the mean CS4. and then click to the run.
Maybe I think I cannot see on your screen.
Yeah. Okay, just I shared the again. Just
Yeah.
a minute, I think. Yeah, that's it. Okay, so now it's visible. Yeah. Yeah. So now it's visible. Yeah.
Yes.
Okay, fine. Okay. So now you can see here I simply put here the reduced region and calculated the minimum pixel value. Okay, I find out the result look like that. You can see the minimum pixel value. Okay, so this is the minimum pixel value of this data set. Just I simply copy from here and then paste as a minimum pixel value. Just put in here. Okay. Same approach, I calculated the maximum. So just I use here the max result. Okay, and click the run. In this time, I can get the maximum result from this data set. So you can see it loaded. And I export the data as a TIFF format and import the data in ArcMap software. It directly showing the value for the mean and max value. I directly find out. But in Google Earth Engine platform, it's not showing the result. So that's why we put here the randomly this range and show the result. But if you want, you can also calculate it the minimum maximum pixel value using the reduce region function and then put it. So it calculated now maximum pixel value from this average data. What is the maximum pixel value or maximum concentration value of methane? It calculated that and we can get the result in here. Okay, it calculated. You can see the result about that. So almost 2009.48. Copy that value. Okay. So then put here this, max value, and then click the run. So now we can get all of those pixel value which are available in my data set. I consider all of those pixel value, mean and max, and display this map. Okay. So now it also proper displaying the map about the mean and max value. Okay, because in the data set, average data set, we find out the minimum pixel value is that, and also find out the maximum pixel value is that. Okay, that I put and visualize the result look like that. Okay, as well if you can also check the color, there is no problem about that. Okay, so this is the way when you want to put here that, and when you just import the data as a export the TIFF format, then it will be automatically showing in ArcMap or QGIS software. Just import the TIFF image, it automatically showing what is the lowest, what is the highest result about that. Okay, so I hope you can got the answer about that. Any question? Okay, anyone any question about that?
Question, sir.
Yeah, please.
Today the network is not quite clear. We have difficulty in understanding and visualizing what you are doing.
Okay, difficult to understand the visualize your screen. Okay, so I hope now it will be okay. You can see here. Okay, so now it's okay. Yeah. You can get this mean and max value and visualize that. Okay, so I also put that another example, then also better. Just a minute. Suppose in this time, I just work with for the nitrogen dioxide and try to show you the again about this concentration about the nitrogen dioxide and visualization also. Okay, so I simply click on the nitrogen dioxide